So question number 6, we're just trying to find the region enclosed by the curves. So we have to sketch it and find the area. So on number 6, if you're finding out where they meet, one of them is y equals the square root of x minus 1. The other one, x minus y equals 1. So if you solve for the y, that means y is x minus 1. Okay, so to figure out where they meet, square root of x minus 1 equals x minus 1. So square both sides. X minus 1 equals x squared minus 2x plus 1. Set it equal to 0. That factors into x minus 2, x minus 1. So our intersection points are at 1 and 2. For our sketch, y equals x minus 1, that is just a line. Y-intercept is -1, slope is 1, so up 1 over 1. You can plug in points if you prefer, or just do your rough sketch like that. Remember, I'm not really checking that your graph is super accurate, you just need to have a rough sketch. Square root of x minus 1, you can't do a 0 if you put in a 1. Square root of 0. If you put in a 2, you get the square root of 1. And you can put in more, like you would have to put in a 5 in order to get out a 2. So remember, our square root graph kind of looks like this. So my intersection, I'm finding this area right here. So we already know it goes from 1 to 2. We're doing it in terms of x, so then it's top minus bottom. Which one is on the top? Okay, so there's top minus the bottom is the x minus 1. All right. Square root of x minus 1. That's like x minus 1 to the 1/2. So the antiderivative, you add 1 to your power, so 3/2. You need the reciprocal in front, so 2/3. Derivative of the inside is 1, so we don't have to add anything else for it. Minus antiderivative of x would be 1/2 x squared. If we distribute that negative, it would be plus the antiderivative of 1 is just x. And we're going from 1 to 2. So then if we plug in, okay, if I put in a 2, 2 minus 1 is 1, and 1 to any power is still 1. Minus, if I put in a 2, 2 squared is 4 times 1/2 is 2, plus 2. Put in a 1. 1 minus 1 is 0, so 2/3 times 0 is 0. Minus 1/2 plus 1. So I get 2/3 minus 1/2, which is 1/6. Is that one okay? Did you get what you needed down on your paper? Okay. And then you said you were having trouble with number 7?
Yeah.
So we need to know y equals the square root of x, y equals 1/2 x, and x equals 9. So first let's find where these meet. So if the square root of x is equal to 1/2 x, so if you square, x is 1/4 x squared. Bring that over. Take out an x. Then we get x to be 0 and 4 in your graph. X equals 9 is just a vertical line at 9. It's basically giving me my stopping point. The square root of x, square root of 0 is 0. 1, 1. 4, 2. 9, 3. 1/2 x. It's a line, y-intercept intercept is 0, slope 1/2. Okay. So what happens is we have two sections here. There's a chunk here, but there's another piece over here. And so since I'm looking at all three curves, I have to do both of those. So the first one, it starts at 0 and it ends at 4. The next chunk starts at 4 and ends at 9. All right, you do top minus bottom. So in the first part, the square root is on top, so it's the square root of x minus the bottom, which is the line, the 1/2 x. And the next part, the line is on top, so 1/2 x minus the square root of x. So square root of x, that's x to the 1/2, so add 1 to the power, that's 3/2. So you go 2/3 in front. Antiderivative of 1/2 x would be 1/4 x squared. This one, antiderivative of 1/2 x would be 1/4 x squared minus 2/3 x to the 3/2. So plug in. Square root of 4 is 2, cubed is 8, so we get 16/3 minus 4. Minus, put in 0, we get 0. 9 squared is 81, so 81 over 4. Squared minus 3, cubed is 27, times 2/3 would be 18. All right. So then we have, this will be 16 over 3 minus 12 over 3. So 12 over 3. So 59 over 12. If my math is right. So because these met twice, and I asked you to go all the way to x equals 9, that's why we had to do both parts added together. So if you think about the pictures, y equals 1 over x. So if you're graphing that, 1 over 0 is undefined. 1 over 1 is 1. 1 over 2 is 1/2. 1 over 1/2 will be 2, right? So it's looking like this. It also exists over here, but it does say that x has to be greater than 0, so I only care about that part. Y equals x is just a line. Y-intercept is 0, slope is 1. So we do see that these two intersect at a point. It's at plus or minus 1, but we already know that x is positive, so we only care about the positive one. The next curve that we are given is y equals 1/4 x. So that's a y-intercept of 0, slope is 1/4, so of 1 over 4. So I can tell from my graph, I'm looking for where that one meets here. If you set the two lines equal to each other, so those two meet, you can tell from your picture. Or if you solve it, 0 equals 3/4 x. So that's just 0, is that first intersection. intersection, so my interval will start there. And then if you find where these two meet, we just multiply over the x and multiply over the 4, plus or minus 2, but we only care about the positive, so just 2. So a lot of intersections, which we could kind of tell if we have a good graph, we can kind of tell where they are, and it helps us a lot. But we are going to have to break this one up, because we can see between 0 and 1, I'm talking about these two curves, and between 1 and 2, I'm talking about a different 2. So between 0 and 1, my x is on top, and my 1/4 x is on the bottom. Between 1 and 2, the top is my 1/x, and my 1/4 x is on the bottom. So that's why a good picture is so helpful here. You can integrate from this point or combine like terms first. The antiderivative of x would be x squared minus the antiderivative of 1/4 x would be 1/8 x squared. What's the antiderivative of 1/x? Antiderivative of 1/4 x, 1/8 x squared. So if I put in a 1, so 1 minus 1/8 would be 7/8 plus the natural log of 2 minus a half. What is the natural log of 1? It says e to what power equals 1? 0. So this is a 0. Oh, hold on. I have a mistake, don't I? What's the antiderivative of x? Yeah, I dropped off my 1/2. I don't know if I even said it. So this would be 1/2 right here. So that would be 3/8. Okay. So we have 4/8, which is 1/2 minus 1/2. So that all cancels. And we just get the natural log of 2.